Hi. So today we're going to talk about one-way ANOVAs. So ANOVA stands for Analysis of Variance, and it's also known as the F-test after Ronald Fisher, who created the test. You're going to use one-way ANOVAs when you have one independent variable with multiple levels, and I'll explain that a little bit more in detail when we get to our example problem. So one-way ANOVAs are also going to be used when you are comparing two groups. One-way ANOVAs always use interval data, so make sure you look for those keywords such as scale, test, score, any kind of numerical data. And they also test the hypothesis of difference. So when you're dealing with one-way ANOVAs, you can have either independent groups or paired groups. So if your people in your experiment are in different groups, then they are independent. If they are in the same group, they are paired. So either way, you're going to have one independent variable. But if you have your people in an independent group, then you have a one-way independent ANOVA. And if this is the kind of problem that you're dealing with, if you reject HO, make sure that you use two keys to see where the difference between the two groups is. Now, if you have paired, then you are going to have your one independent variable and you're going to have a one-way within groups ANOVA. So before we begin, I want to go over some symbols or terms. Some of these you may have seen before and some of these may be new to you. For one-way ANOVAs, you're going to be looking at SST, SSB, and SSW, which stands for sum of squares total, sum of squares between groups, and sum of squares within groups. You're also going to be looking at MSB and MSW, which is the mean square between groups and mean square within groups. And then your final calculated value is going to be F. So in other statistical problems, you would use M for mean and N for how many people are in your experiment or in your study. So for ANOVAs, because you're comparing different groups, it's done just a little bit differently. So in ANOVAs, a small m or lowercase m is for the mean of a group, whereas a large M is for the mean of an experiment as a whole. A lowercase n is for the number of people in a group, and a uppercase N is for the number of people in an experiment. And a new symbol that you may not have seen before is K, and K is going to stand for the number of levels or conditions for your independent variable. So these are the formulas that you're going to use to solve one-way ANOVAs, and I know they look super complicated, but trust me, once you actually get into it, it's really not that bad. So go ahead and pause the video and write down all of these formulas. Okay, so let's get started. A researcher wishes to test the effect of shock on memory of verbal material. Group A receives no shock, Group B receives a medium shock, and Group C receives a high shock. All participants are then given a verbal retention test. So let's go ahead and start out by identifying what our independent and dependent variables are. So our dependent variable is something that we are measuring. So what are we measuring in this instance? In this instance, we are going to be measuring the verbal test. So the test is going to be our dependent variable. So that means that the shock is going to be our independent variable. So how many levels of our independent variable do we have? We have three because we have three different groups. So we have A, B, and C. So our levels for the independent variable are 3. So let's go ahead and look at our data set and start getting some of the numbers. So if you look at your formulas, so here's one of the formulas that we're going to use. Some of the symbols, remember how I said they looked really complicated, but they're really not that hard once you actually get into it. It's a lot of the stuff that you've already done. So take, for example, this is the sum of the raw scores squared, and then there's a value 1 here. And then there's the same thing over here, squared value 2, squared value 3, and you can see things like that throughout the formula. So all that you're going to do is you're going to add up the raw scores and you're going to square them just like you've done in all of your other statistical tests. You're just doing a little bit more detailed labeling. So you can see here that you've got the sum of the raw scores, 1 for group 1. the sum of the raw scores squared for group 1, and then N1 is the number of participants in group 1. And you're going to just do the same thing going all the way down. So you have the sum of the raw scores for group 2, the sum of the raw scores for group 2 squared, and then the N value for group 2. And then you do the same for group 3, and then you've got down here at the bottom, you have your large N, which is how many people we have in our study altogether. We have our K value, which is the level of conditions, which we just talked about, and that was 3 levels. And then we have the sum of the raw scores here as well. So this is going to be this value, and this value all together. So let's go ahead and get started on that. So first, let's find our sum of raw scores for group 1. So what we're going to do is we're going to add all of these numbers up here. So when we do that, we are going to get a value of 123. So we're going to put 123 here. And then we can go ahead and do that for these other groups as well. So we're going to add all of these values up here. We're going to get 97 for this group. And then for group C, we are going to get 73. Okay, so now we just have to square all of these and then add all of those up together. So when we square all of these, 24 squared is 576, and then 30 squared is 900, 25 squared is 625, 24 squared is 576, and 20 squared is 400. Okay, so we're going to do the same thing. We're going to add all of these numbers up here, and when we do that, that is going to give us 3,077. Okay, so we're going to go ahead and write that value here, 3,077, and we're going to do the exact same thing for all of these other groups. Okay, so I went ahead and did all of that. So when you square all of these values and then you add them up, for group B, you are going to get 1897. And then for group C, you are going to get 1077. Okay, so now let's go ahead and fill the rest of this out. So how many people do we have in group 1 or group A? We have 1, 2, 3, 4, and 5. Okay, so there's that value, and we have the same number here, and then we have the same number here as well. Okay, so when we add all these together, that's going to give us our N value here. So that's going to be 15. And then for the sum of the raw squares, like I said, we're going to add this value, and this value together. And then when we do that, that is going to give us 293. Okay, so now we have every piece that we are going to need to solve all of those problems. Okay, so let's go ahead and get started by solving SST, and our formula is down here. So we're just going to take some of these values from here and we're going to plug that into our formula here. I have gone ahead and drawn up a little chart to kind of keep our information organized. This is exactly what you're going to see on your homework, and it'll just allow us to put all of our answers in one spot, and then that way we can clearly see our results at the end for our F value and our probability as well. Okay, so for SST, we are going to start out by plugging in the sum of the raw scores squared for group 1, which is 3,077. And then we're going to add that to the sum of raw scores squared for group 2, which is 1897. And then we're going to add that to the sum of raw scores squared for group 3, which is 1,077. Okay, and then we are going to subtract the sum of all of the raw scores, which is 293, and then we're going to square that, and we're going to put that over our N value of 15. Okay, so all we have to do now is solve all of that out. So when we add these values up here, 3,077, 1897, and 1,077, that is going to give us a value of 6,051. And then when we square 293, that is going to give us 85,849. And then we're going to put that over 15. So we just continue solving that. So let's go ahead and divide that out. So that's going to give us 6,051 minus 5723.27. Don't forget to round. Okay, and then we just subtract those, and that is going to give us a final value of 327.73. Okay, so our SST is going to be 327.73. So let's go ahead and get our table out here and record that value in. So SST, it's going to be right here. So we've got 327.73. Next, let's go ahead and solve for the sum of squares between groups. So we're going to do exactly what we did before. We are just going to plug in our values into the formula. So let's start out with our sum of raw scores for group number 1. So that is this value here. So that's 123. That's going to be squared and over our in value for that group, which is 5. And then we are going to add that to this value here, which is the sum of raw scores for group 2. That's this value here. So we've got 97. That's going to be squared and then over 5. And then lastly, we're going to do the sum of raw scores for group 3, which is this value here. That's 73 squared, and then that's going over our in value as well. And then we are going to subtract. This is the sum of the raw scores for the all of the groups, which is 293, and then that is squared, and then that goes over our other in value here, which is the total for all the groups, which is 15. Okay, so let's go ahead and start solving that out. So 123 squared is 15,129. Put that back over 5, plus 97 squared is 9409 over 5. And then 73 squared is 5329 over 5, minus 293 squared is 85,849 over 15. Okay, so then let's go ahead and divide those out. So 15,129 divided by 5 is going to give us 3025.8 plus, and then divide this out. That will give us 1881.8 plus, then divide this, 1065.8 minus, then we divide this out to give us 5723.27. Okay, so now we can start adding and subtracting. Let's go ahead and do those. So when we add those two values together, that's going to give us 4907.6 plus, and then we just add this down here, 1065.8 minus 5723.27. Okay, now do these two numbers here, and that's going to give us 5,973.4 minus this value here of 5723.27. And then we solve those out, and that is going to give us a final answer of 250.13. So our sum of squares between is going to give us 250.13. And then we go ahead and take our table and add that into here between groups. So we have 250.13.